So in this video, we're going to be looking at Newton's method. So Newton's method is a way to approximate roots of functions. So there's a way we can do this. So let me write out the formula first for Newton's method, and then we can go about from there. So the formula for Newton's method is follows: x sub n is equal to x sub n minus 1 minus f of x sub n over x sub n minus 1, sorry, it's not x sub n. Let me get this. So f of x sub n minus 1 time over f of x sub n minus 1 prime, f prime of x sub n minus 1. So this is the formula. So let's try to understand this formula by understanding what Newton's method does. So Newton's method basically is a way for us to approximate the root of a function like this. Let me say that we had, let me draw a Cartesian plane for y, x, and let's say that we had a function like this going through the x-axis at this point. This is going to obviously be identified as the root, right? Now, if this point is the root, we don't know this point because let's say that we couldn't find this point. But what we would do with the Newton's method first is we would find an x value as a guess for what the root can be, and that is actually going to be your nth guess, which is your first guess, right? N is equal to 1 in this case. So let's just say this is x sub 0 because n is equal to 1. That's x sub n minus 1, which is 1 minus 1 is 0. In this case, we're telling that this is our root, which is obviously not going to be the case. But in order for us to determine if, in order for us to use Newton's method, what we have to do is we have to draw a tangent line going through this point. Now, the tangent line is going to cross the x-axis at a point. Now, in order to determine the point that the tangent line crosses the x-axis, that's quite easy, right? We can just normally use our normal algebra, and we can just get x is equal to, we can set f of x equal to 0, and we can do that for the line. Now, this is going to be our new point that we cross, and this is going to be our x sub 1. This is going to be our next estimate, or next guess. So going up, this is going to be x sub 1. This is a point. Now, if we draw another tangent line through this point, right, we get even closer. Whoops, that's not good. Let me draw this again. Then we get even closer to the point, right? We get closer to the point. And this is where we cross. So we can just keep on doing that, and as we will see, so this is our new point, and then it's going to cross here, and then draw another line, right? Draw another line, and look at that. It's crossing it very, very close to the point. So just keep on doing this. So basically what you're doing is you're looking at a point, and this is going to be x sub 2, and this is going to be x sub 3. You're looking at a point, and you're just going to look at the tangent line for that point and look at where it crosses the x-axis. And then that's going to be your new point, and just you're going to keep doing that until you get closer and closer to the point that you're looking for. And you are going to get closer and closer in many cases, and that's going to be your approximation for the root. And this is basically Newton's method, right? This is what you're doing in Newton's method. It's not going to work all the time, but it is going to work sometimes. So for some functions, it's not going to be working. It's just going to keep on going to random points. It's not going to settle at one point. But in some cases, the tangent line is going to come and settle at one point, and multiple times it's going to keep on getting that point, and that's going to be your root. So this is a formula for this. Let's try to do an example. Let's say that the function f of x is equal to something like 2x squared. Now I just want to keep it easy here. Maybe I'll just do x squared, even easier. And obviously this is easy to find the root, right? We can just set 0 equal to x squared and x equal to 0. Now Newton's method wouldn't be needed, but if we were to use Newton's method, we can try. So x sub 1 is going to be equal to x sub 0, which is going to be equal to my first guess, which is equal to, let's say, 1. So 1 minus f of 1, which is just 1, over f prime of 1, which is just going to be 2. This is going to be x sub 2, or sorry, x sub 1, not x sub 2, x sub 1 is equal to 0.5. Now, x sub 2 is going to be equal to x sub 1, so that's just going to be 0.5 minus 0.5 squared, which is 1/2 squared is 0.25, over 2 times 0.5, which is just 1. So this is going to be x sub 2 is equal to 0.25. Now, if we keep on doing this, we'll see that we're just going to half each time. So 0.25 times 1/2 is going to be 0.125 times 1/2 is going to be whatever that is. Let me see. 0.125 divided by 2, 0.0625. Divide this by 2, 0.03, 0.03 dot dot dot, x sub 6 is going to be equal to 0.01. Notice we're just going to keep on doing this. We're going to get closer and closer to our value. We're just going to get closer and closer to 0. And that is, of course, our original root. So Newton's method works. This is obviously not a case that we can use Newton's method because it's not necessary. But for other functions where it's hard to just find the root by factoring or something like that, we can use Newton's method to approximate. And calculators actually do use this kind of logic to find an approximation. It's not going to be the exact value, but it's an approximation. This is Newton's method. I hope you found this video helpful.